Welcome back. It is time for another throwback to the factor theorem and remainder theorem. So let's take a look at this again, just to refresh ourselves. We can say that the binomial x minus a is a factor of a certain polynomial if when you divide the polynomial by the binomial, you get 0 as the remainder. So just keep that in mind. And now we're going to try to learn how to cover a new type of problem, how to solve a new type of problem. Determine the required value of c in the polynomial x cubed plus 2x squared plus cx plus 10. So what value should we put here in order for x minus 5 to be a factor of f of x? Well, let's think about that. So we can either guess and check. We could set up a whole bunch of different long division problems and try out different values of c. Since this is a factor, then the remainder should be 0. We have to guess and check what are different values of c that we can put in to eventually divide out and have no remainder. Well, that could take a long time, so there's got to be some sort of easier way, unless we're really good at guessing. So we're going to use the factor theorem. So in order for this to be true, we can say that when x is 5, the result must be 0. So this keyword here, factor, if this is a factor, then this here, right, is one of the terms that multiplies to make the equation. So this is basically a mini equation that lets us know, oh, it's going to be an x-intercept because it's a factor going to cross at that certain point. So that's where x is 5. So we know the point 5 comma 0 is on this graph. So let's use this point here. We can substitute in 0 for f of x and 5 for x. And then we should have only the c variable remaining. So that's what we're going to end up doing. Should take a lot less time compared to guessing and checking. All right, so that's us set up. And now it's time to do the algebra, order of operations. So I'm doing my exponents first. I'm going to rearrange this here and write 5c, because that's just the proper way we write our coefficients and variables, and then plus 10. Got to multiply some. Right, and then collecting all these like terms, the constants add up to 185. So 185 plus 5c equals 0. Simple as that. We just move over the constant, subtract 185 from each side, and then divide each side by 5. Get negative 37. So this polynomial, when we replace c with negative 37, that should make this statement true. Now we'll look at a problem real quickly with the remainder theorem. we've got this polynomial function here, and they said that when they divided it by the polynomial x plus 1, the remainder was 14. Using those facts, we should be able to find the value of k in the polynomial. So, using these facts, we could either take this and divide by that using different types of k and seeing, well, what value of k is going to make the remainder be 14, negative 14, or we're going to know that there's a certain point located on the function. Using what we know about remainder theorem, this number right here is important, and then the remainder is important. The remainder is the y value of your function. And then this is acting sort of like your root. So you got to think, what makes x plus 1 equal to 0? When x is negative 1, that will make it 0. So negative 1 is our x value here. You can also just take the opposite of this value that you see. So I know that this point exists on the function. I'm going to replace x with negative 1 and f of x with negative 14. And then just turns into a simple math 1 or math 2 problem. Order of operations. Negative 1 squared is 1 times 3 is 3, and then that turns into a negative 9. So combining those like terms, we see that we need to add 6 to each side. And then finally we get a k value of negative 8. Okay, so it's mostly just knowing the background information. What part means what part of the ordered pair, and then we'll use that ordered pair to substitute back into the original equation. Now there's usually a question like this, just like this on the EOC, so that's why we're spending some extra time going over it. Okay, we'll look at the question prompts for 2 more. Got these 2 problems. I've written them down shorthand on the page. So this polynomial, and this is a factor. We want this to be a factor. So I'm going to use this fact, and then this fact, what we know about factors. It's going to be an x-intercept basically. So we've got the opposite of negative 2, positive 2. 2 comma 0 should be a point that exists on this function according to what they said about factors. So 2 replaces x, and 0 replaces y. Then just working through this algebra real quick. Looks like k is going to be negative 7. Okay, so we could put negative 7 in place of k. And if we wanted to do the polynomial division to check, or in the place of this k, we would need to do the polynomial division to check that and hopefully get a remainder of 0. And then the next one is going to use the remainder theorem. When divided by x minus 5, we found a remainder of 91. So remainder is important, and this part is important. So I'll take the opposite of negative 5, which is positive 5. And then 91 is my y value. Let's figure out what value of k makes this equation true. When we substitute in 5 for x, 91 for f of x. Okay, so we've got 105 plus k equals 91. Subtracting away 105 tells me k is going to be negative 14. Okay, so that's how you solve that type of problem. Application of the remainder theorem and factor theorem. Thank you.